In this equation, I am to solve for the input variable t. Because the input variable is in the exponent position, this is considered an exponential equation. One way to solve an exponential equation is to follow this four-step process. So for example, step 1 is to isolate the exponential expression. This is the exponential expression because it's the base that's being raised to an exponent with the input variable in it. We need to isolate that or get it by itself by getting rid of the negative 70 that's being multiplied and getting rid of the 22 that's being added. Once I take the 22 and the negative 70 to the other side, that'll change what this number is, but it won't change the fact that I'll have this structure. I'll have a constant, 1.37, raised to an exponent, which in my case is t, and that'll be equal to some other constant. In fact, it'll be the constant that you get after taking the 22 and the negative 70 to the other side. So let's do that now. So step 1 would start by subtracting the 22 on the left-hand side, in which case it would simplify out, leaving me with just this. I've written that down. But then you'd have to subtract 22 on the right-hand side, so it would look like this. After I simplify this number, since the negative 70 is being multiplied, I'm going to divide both sides by negative 70. So dividing the left-hand side by negative 70, and now I'll need to divide the right-hand side by negative 70. Negative 70 divided by negative 70 is 1, so that simplifies out. Anything times 1 is itself, so my left-hand side will simply be 1.37 to the t, and the right-hand side simplifies down to be 75.5. Now, one of my goals in this video is to find an exact answer. Even though I may have simplified this number by using a calculator, it's important to point out that I did not round. My calculator gave me exactly 75.5, which means it's a terminating decimal. Since this number is exactly 75.5, meaning it only has one decimal, and I've given that one decimal place, this is still an exact answer even though I used a calculator. Now that I have the problem to have this structure, I'm done with step 1. My constant is 1.37, my exponent is t, and what I've written here as some other constant is my 75.5. This has to be done before you can take the natural log of both sides, which is step 2. Step 2 in the process simply says take the natural log, abbreviated ln, of both sides of the equation. So this is where I left off. Now to apply step 2, you can always write exactly what you see here. The ln of parentheses equals ln parentheses, and simply plug the left-hand side of the equation in there, and plug the right-hand side of the equation in there. I'm literally taking the left-hand side of the equation and putting it in the parentheses, and literally taking the right-hand side of the equation and putting in the parentheses here. That's all there is to step 2. One of the reasons for doing step 2 is that there's a logarithm property that says if you have a logarithm of a base raised to an exponent, that exponent can be moved down in front as multiplication. That would be step 3. If you go back to step 3 says if the base is e, mine is not, so I'm going to ignore this. If the base is not e, which is my case, my base is 1.37, move the exponent down as multiplication. Doing that would leave me with this statement. Notice that this is no longer an exponential equation because my input variable is not in the exponent position. In fact, this is a linear equation. So now I'm on step 4 because step 3 was simply to bring down the input variable as multiplication. Because the equation is simply a linear equation now, I assume students know how to solve for t. So step 4 just simply says solve for the input variable and gives no directions. I'm assuming you know that since the natural log of 1.37 is being multiplied by t, we can isolate t by simply dividing both sides by the ln of 1.37. So I'm going to simply divide the left-hand side by ln of 1.37, and I divide the right-hand side by the ln of 1.37. A number divided by itself is 1, so this simplifies down to be 1 times t, which is just t. So I'd be left with t equals this number here. If you remember, I never rounded anything so far in the problem, so this is what we'd consider an exact answer. Some teachers and some students like to use a regular logarithm, log, which is base 10, rather than the natural log, in which case the answer would look exactly like this, except for where you see ln, you'd see the word log. I will type both versions in the calculator and to show you that you get the same answer either way. So I'll start by typing the natural log of 75.5 divided by the ln of 1.37. I'm going to round to 4 decimal places. So to 4 decimal places, I'll have 13.7357. Since this number is 5 or higher, I'll round this digit of 6 up to a 7. I'd write my answer now using this notation rather than an equal sign, I call it a squiggly equals, to indicate that this is only an approximation. I use an equal sign for an exact answer, and I use this symbol to tell people that it's been rounded. One last thing, notice have I typed in the log base 10 of 75.5, which is indeed different than the ln of 75.5, but then if I was to also type in divided by log base 10 of 1.37, and log base 10 of 1.37 is different than the natural log of 1.37. So even though these two numbers are different, and these two numbers are different, it turns out the ratios are the same. Notice I get the same answer either way using a logarithm of base e, called the natural log, or a logarithm of base 10.